Testing. 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 All right, looks like we got it. A little bit better angle here. And we're good. Alrighty. Welcome to another Hoopo stream. We got some GitHub repo today. We got LangChain. So LangChain is a repo that has been kind of gaining popularity here. It's for building applications with LLMs. So largely the purpose of this is to kind of wrap a couple different things that people always want with LLMs and then make them in a convenient way. So you see there's a couple different parts here. There's basically abstractions for LLMs and prompts, for chains, for agents, which I think is the big one. It's kind of like an auto GPT kind of thing. And then as well for memory, so different memory implementations, perhaps some vector databases. As you move LangChain into production, so it seems like they're going to look to make money with support, some kind of enterprise tier, but of course they're going to need to have the freemium tier, right? MIT licensed code, so maybe the hosting is what they make money on. The real power comes from when you can combine them with other sources of computation or knowledge. Documentation, question answering over Notion database. This is the demo that I saw that's actually quite good, but we're gonna wait a second to look at that until we understand a little bit better. So this is the documentation of LangChain. This seems like it's crafted automatically. If you actually go here into the docs folder within the repo, you can see that here is actually where the documentation is held. So you can edit this documentation by clicking on here and editing it. Let's see. Call out to a language model, but also be data aware. Okay, so that seems to be the main component. And then agentic. Allow a language model to interact with its environment. So some kind of like RL magic fused in here, although I don't think it's actual reinforcement learning. Here are different modules, which basically just means the different abstractions, right? You got models, which is going to be your actual machine learning model like GPT. You got prompts, so some kind of object built around prompts. Conceptual guide. Let's see what that says. You got the prompt value. You got a class for that. You got prompt templates. Example selectors. Output parsers. So somebody went crazy with the object-oriented design, basically, and then just kind of seems like that's what LangChain is. Memory. Do they have integrations with anything interesting here? Conceptual guide. Python, JavaScript. Fetch any relevant pieces of data. Similarity search. Based on input and output, update state accordingly. Short-term and long-term memory. I don't think that's actually an LSTM here. This is probably just a database. Indexes. Okay, so this is the actual SQL tables, document loaders, text splitters. Right, so if you load a big PDF, you're not going to want to feed that all into the GPT API all at once. So being able to split a text intelligently and then feed the different chunks into GPT is important. We've definitely run into that problem in our projects. vector stores. Here's your actual vector databases, and then retrievers. What type of stores do they support? So here are all the different ones they use. Pinecone. We've heard about that one before. Elasticsearch, FAISS. This is the Facebook one that we see pop up over and over again on a variety of different repos. You got Chroma, you got Atlas DB. So they got all of them. But we don't really know what the quality of those integrations is, to be honest. We got chains, agents. Chains go beyond just a single LLM call and are sequences of calls, whether to an LLM or a different utility. LangChain provides a standard interface for chains, lots of integrations with other tools, and end-to-end chains for common applications. So chain is maybe a way of storing a conversation, it seems like. I don't know why they necessarily have you see here, they're basically, it's all these abstractions that they've built. So they have LLM chain, they have prompt template, they have OpenAI. So this feels very similar to something like PyTorch Lightning, I would compare it to, or any of these other Python-based modules that basically just take already existing stuff and then build these object-oriented abstractions and then wrap it all together and try to give you a simpler interface to deal with and something that's easier to deal with. But sometimes it's kind of a double-edged sword, and it ends up being more annoying than just using the raw thing yourself, because a lot of these abstractions end up being very opinionated, and if you want to do anything that isn't kind of part of the abstractions, then it becomes very difficult to do anything. Okay. Agents. This is, I think, the most interesting part. Conceptual guide. So you can give your agents tools. You can give them there's different types, I guess, and then tool kits, I guess, as maybe sets of tools or something like that. So let's see. Give me the Python guide to the agents. Okay, so here are all the different tools that they have available right now. So you got Archive, Bash, Bing Search, Google Search, Wikipedia, and Wolfram Alpha. So this is pretty good. That's like kind of, I would say, the minimal set you need to be pretty useful. Bash is interesting too, because then this basically becomes a superset of AutoGPT. Agent executors take an agent and tools and use the agent to decide which tools to call and in what order. Vector store agent. So this is an agent that you see here, document loader, import text loader. Text loader loads a specific text. You use the character text splitter object to split the text into little texts. OpenAI embeddings object, I guess. And then it converts the text into embeddings and then stores it in a Chroma, I guess not Chroma, but DuckDB is where it stores it. And in memory here just basically means that it's storing it on your computer in memory, right? It's not actually putting it into a hosted database somewhere. Web-based loader. So that's kind of cool. You can load websites and then split them. Using DuckDB, data will be transient. Here's the actual agent call. You got vector store info object here. Description, vector store. State of union store. It's not even defined anywhere. So this is kind of what I'm talking about, is that sometimes, even though these abstractions make things nice, you haven't really used it. So you don't really know the abstractions as well as the people who design the software know them. So for the people who design the software, it seems like these abstractions really help. But for people who don't know the abstractions, it just ends up taking longer to learn the abstractions. Confusing to use, too abstract. Do you have experience, RW, using it? It just seems like it has like 1,000 different objects. You know, it kind of feels like AWS or like one of these cloud services where you go in and there's like a bajillion different things. And you have to kind of figure out what's going on. But I thought this demo was cool. So let's do this. Let's play around with this. So this is a demo that someone built using LangChain, and it's a ChatGPT, right? That you can talk to. So, I mean, this is using 11 Labs and Whisper. So this is the same tech stack that I used for my thing. But they have this little face here, which makes like, it just adds like an extra level of creepiness to it, right? So you need to paste your OpenAI key here. And one tip for you guys is you can make a OpenAI key, right? We'll call this test. Create the key, copy it, and then put it in here. And then whenever you're done, just delete that key, right? Because you don't want to have your key sitting out on the internet, because if you have it sitting out on the internet, someone can take it and they can start using it. So you use it, you create a new one just for the purposes of whatever you want to do. We're just going to test out this little chatbot here. And then once you're done with it, just delete it so that it no longer exists. So let's go ahead and ask this little chatbot what's going on. How is it going? Stop recording. Great, it's broken. What is it? What are you most excited about in the future? And I love this like little creepy dude here. Like, we can let's do enable speech too, so he'll talk to us. Let's see what he has to say.
The potential for artificial intelligence to help us solve some of the world's most pressing problems. AI can help us make better decisions, automate tedious tasks, and even help us understand complex topics. I'm also excited about the potential for AI to help us create new and innovative products and services that can improve our lives.
That was terrible. Let's see. They have some stuff here. Formality, polite, casual. Let's go honorific, full. Settings. Let's give it Wolfram Alpha. Show talking head. Use GPT-4 if your API. No. Emotion. Ecstasy and trust. And let's go back. Reset chat. Show talking head. Reset chat. All right. Show me what you can do with Wolfram Alpha. Let's see. It's doing something.
And faith in the remarkable capabilities of Wolfram Alpha. which can be used to answer an array of inquiries, from basic computations to intricate scientific and engineering issues. Furthermore, it can be employed to create visualizations and graphs, as well as to offer comprehensive explanations and descriptions of topics.
Can I like change this guy's face? This guy's face is a little creepy. Show reasoning chain in chat bubble. Oh, okay. I think this is what we want. So we can see inside its brain, right? So these LLM agents, at this point, like a lot of the conversation that they're having and a lot of the prompts are internal to their own narrative. So we can't even see it. So like, for example, if we say, what is 8 plus that? Hopefully we should see that it asks itself internally to use Wolfram.
293847 is a glorious 293855, a number that fills us with joy and faith.
There's something so creepy about that. Do I need to use a tool? No. Can you, or let's see, what is the derivative of x to the third? I feel like it should have to use a tool for that, right? I'm really curious what they're using for this face.
Of mathematics. With utmost trust, I proclaim that the derivative of x cubed is a wondrous 3x squared.
I mean, that's a correct derivative, so it turns out that you don't actually need Wolfram Alpha. You see how it's asking itself, do I need to use a tool? No. And then this is the actual one. Let's see if we can make it no good. So let's make it more casual, and then let's make it loathing, anger, loathing and anger. All right, let's go back here, reset chat. What is the derivative of cosine of x? How does it know whether to use a tool or not? So there's a part, let's see it answer this, and then we'll answer that question, RW.
X has to be the most annoying function ever, and of course its derivative has to be sin x.
I feel like it just hits harder, right? Like whenever you're interacting with ChatGPT, like it doesn't feel like it feels a little alien, but like you can kind of separate your mind from it. But as soon as you put this guy's face there and you can see his lips moving and he's just like sitting there just staring at you intensely, I feel like it changes the equation, right? I wonder what they actually used for that. Let's answer your question. So here, when we were looking at the agent executors, I guess here, no, agents tool right here, tools, Python guide, conceptual guide, toolkit. So I think it basically determines if there's a separate agent which asks itself, do I need to use a tool in this case? And then it answers its own question. So the kind of chain of thought style prompting, where normally you're prompting the ChatGPT and it only is allowed to answer the questions that you ask it, right? You ask it a question and it answers. But these new agents, like agent style LLMs, like they're allowed to ask themselves questions, right? So they can prompt themselves and then answer their own questions. So when I ask it, what is the derivative of cosine x? It prompts itself, do I need to use a tool? No. And then it says, okay, well then here's the answer. And then this is what it actually tells me, right? So I can actually go here and I can say show reasoning chain. And if I click that and I ask it the same question, right? Like what is cosine of x? What is derivative of cosine of x? Now it's not going to show me that internal monologue that it has with itself. Now it's just going to be
X has to be the most annoying function ever, and its derivative is sin x. Seriously?
Yeah, so you see how it asked itself a question, but like it didn't show it to you, which is actually kind of a little bit creepy because right now you, when you talk to GPT-4, you know everything that it's saying, right? You know everything that it got, and then you know everything that it said, and you know the entire context. But more and more, I think the context is going to be hidden from you, and you're not going to be able to see the context, right? You're not going to be able to see what questions the LLM is asking itself internally. Let's go into files here and see what they're actually using, though. Images, videos. Masahiro videos. Images. Is this the PNG of this dude? Yeah, so it looks like they're taking this PNG of this guy, and then they're probably doing the Balenciaga thing where they're like messing with the mouth and then messing with the eyes. Is this what it is? Poly voice data? No, that doesn't look like what we want. We want requirements, requests, Botu, face. So this is the vector DB. Facebook has OpenAI, Wolfram Alpha, LangChain, Whisper, Boto 3. I'm not seeing anything here that is... Let's see if the community, people have probably asked this question. Lip sync animation. How does lip sync animation created? It uses X-Human for now, but wonder what model is under. Okay, so there's X-Human. Let's look at this. X-Human. Explore our digital humans. Create your own digital human. So you can see here we can talk to a little fake Elon Musk. You see, and you basically, you give it a picture and then it'll animate the lips and face for it.
I have a plan to build my own colony on Mars. Do you want to join me?
That is not his voice at all, and it's extremely creepy. Got Bob Marley here. What did you do on 420?
Are you listening to reggae now?
Or 430, I guess. It's going to be confused. Let me think. Okay. This is probably $4.99 per month for up to 10 custom bots and 10K per month. Yeah, I don't know. They're probably not doing anything special. You could probably recreate this in-house integration. Python API. I wonder what other APIs they have. This is a dead link on their website. Safe dating. Brand rep. AI doppelganger. Get an AI doppelganger of a real influencer and stay connected with your fans. Very creepy. Okay. But this video is not about whatever the fuck that was. This video is about LangChain. So let's get back to it. Let's see if we can get this GitHub repo cloned and start messing around, see what we can do. So first thing we're going to do here is they have a quick install. Isn't virtual influencer a thing? It totally is. And I'm already kind of halfway there, right? Like I already have the digital eyes. So at some point, I'm going to have a digital face, and then I'll have a whole digital body, and then you won't even know if it's even me. I've actually already posted a video. So actually on my channel, one of the TikToks that I have, let's see, your channel. Yeah, this TikTok here, GPT makes a catio.
Hey there, TikTok.
That's not actually my voice. This is an AI generated voice that's cloned from me.
Fam, it's your favorite feline duo here. Meet Boo Boo. I asked ChatGPT to help me build a...
So we're already there. Like right now I'm just replacing my eyes and my voice, but I think eventually I'll replace my whole head, and of course I'll pick like a much more attractive head. But yeah, it's going to be kind of weird because you're not just going to be sitting there and typing in order to talk to an LLM. You're going to be talking to it like with words, and it's going to be a little talking head. Where's the installation? Installation. Pip install LangChain or conda install LangChain. So let's make a new environment here. Let's do conda create. And we'll create a new environment. We're going to call it LangChain. Yes. Clear. Let's do pip install LangChain as they suggest. All right. Installed. Good to go. And let's double check to make sure that it works. It does work. Do they have any kind of examples here? Any kind of beginner examples? Set up an installation. Nothing is real on the internet anymore. See, they got a bunch of different code here. So you got JavaScript. JS is JavaScript, very popular. Language, TypeScript, also popular. I do not have very much JavaScript or TypeScript experience. I do have a couple commits to production in TypeScript when I worked at Wannabe, but that's like a while ago now. Quick start. Okay, so once you install it, all of these examples are not in Python, dude. Give me Python. Yeah, this is what I want. Quick start. Okay, so you have to get the OpenAI API key. I'm pretty sure I already have that set. Get predictions from a language model. Let's see if this part works. So let's copy paste that in there. From langchains.llms, import OpenAI. We make a LLM object, which is of the OpenAI class. We'll say temperature equals 0. Actually, we don't even give it a temperature. Let's just do that, and then maybe we have the temperature available. Yeah, so the default temperature is 0.7. Let's say LLM response equals LLM of hello there. Okay, incorrect API key provided. It seems that I have already used up this API key, so let's go ahead and we'll make a new key. So let's delete the key that we were using for that Hugging Face demo in case they like stored it and are now tracking it. And let's make a new one. Let's call this LangChain stream. We're gonna create a secret key. We're gonna copy that, and you guys could theoretically freeze the video at that moment and then take that and then spend the time to copy it, and you can have free OpenAI on my dollar if you want, but as soon as this stream is over, I'll delete that key. So I'm just gonna warn you right now. So let's I kind of don't want to just do this in the terminal anymore. Let's make a directory here, or cd into dev. Make a directory called LangChain. Or actually, why don't we put this in, we had a project that we were working on. What were we working on? Maybe the thumbnails project, right? Like, where do you guys want to try to put LangChain here? Hunt, Diligent, Chapter Gen? What is Chapter Gen again? I forget. I have so many projects. So many projects that I never finish. Repos, speech to speech. Yeah, let's put it in the speech to speech. That's probably the better repo to put it in. So let's go into speech to speech. Clear. We're gonna git pull just to make sure we have the latest one. And let's make a little Python file here called langchain.py, or touch langchain.py, and then let's open up a terminal here. And let's make a new little file here, and we're going to call it openai.txt. We're going to paste our key in there. I'm going to save that. We're going to close that. And let's open it up, langchain.py. And import OS, import OpenAI. And here we go. And let's set the set OpenAI API key to file in root called openai.txt. Come on, Copilot, Copilot. Copilot is not able to do that for us, so we're just going to copy paste it from one of our other GitHub repos. I literally just wrote this code over here in thumbnails. Yeah, so in thumbnails, in generate, this is the, nope, that's not the path I want. I want ops.py. This. Set OpenAI API token, so we'll put that there. And the router is going to be the directory of this file. So in Python, the underscore file like that is the path of this exact file here. So what this is doing is it's basically saying this file here, langchain.py, give me the absolute path of that, right? Which means it'll go all the way to the root. It'll give you the full path for this system, and then it'll say, give me the directory of this file. And that'll give you the directory in which this is contained, which for us is going to be this speech-to-speech folder. So then inside that speech-to-speech folder, it's going to look for a file called openai.txt, which is where we pasted our OpenAI API key, and then it'll go ahead and it'll set the environment variable to that, and then it'll set the OpenAI API key to that. So if you do this design pattern of having your keys in a text, you definitely want to make sure that you don't commit them. So go into your git ignore, right? And then here inside the git ignore, we'll say API keys, and we'll put openai.txt. So once you save that, Git will know to ignore that. And now if you see we go to our commits, we can see that it doesn't want to add that API key anymore. Okay, so we're here in langchain.py. Let's import LangChain up here. Let's do as LC, right? Oh shit, what the fuck was that? Okay, import LangChain as LC. And now let's go back to the examples that they provide here. Boo, what do you want, Boo? Boo just wants to play. All right, let's try out their OpenAI. I also don't like this design pattern, right? So whenever you have this design pattern, you basically have to, right, you don't know that OpenAI is an object that belongs to LC, right? So it's kind of annoying, right? I'd rather be able to say lc.llms.openai, but, and the reason we're kind of getting errors here is because we're not using the right conda environment. So let's switch to a new conda environment that we created, and we called it LangChain, right? Yeah, LangChain, there we go. So now we should have LangChain as LC, langchain.llms. Let's actually close out of this, reopen it. All right. Still doesn't get it. That's annoying. And let's see. print, or let's make the LLM object, OpenAI, and set the prompt. No. Print, hello, my name is, get rid of this, just say hello, what is your name? And I don't think the call is llm.generate, so this is a hallucination here by Copilot, and you just want that. Let's not do that, let's do this. We're not in the right profile. Let's make sure to set our VS Code profile. And let's run this Python file. Import OpenAI, no module named OpenAI. Okay, let's close out of that. We're going to need to conda activate LangChain. Pip install LangChain. Pip install OpenAI. Clear code dot. Now we got this good old bad boy. Let's rerun it. No module named LangChain.llms. LangChain is not a package. Okay, so the problem here is that we tried to be fancy here and import it like that, but we cannot do that, and let's rerun it. Oh. Rerun, come on. This is some hot garbage right here. Let's see what even works here. Import langchain.llms or from. Well, that's no good. That means the installation wasn't correct. Let's see, pip install LangChain. Oh, I think maybe you need a conda specific one. Let's try that. Collecting package metadata, solving environment. Prompt template. Calling an LLM is a great first step, but it's just the beginning. When you use an LLM in an application, you are not sending user input directly. Instead, you are probably taking user input and constructing a prompt and then sending that to the LLM. So what is this installing? Is it installing NumPy, PyYAML, data classes, JSON, cryptography, what the fuck? Brotli Py. There's some weird shit going on here. What? How is that not? Doesn't make any fucking sense. Python 3? Maybe we're using the wrong Python? LangChain is not a package. Ugh. What the fuck is going on? Okay. Let's conda deactivate. Clear conda activate speech to speech. Clear. Pip install LangChain. Let's make sure it's spelled correctly. Pip install LangChain. Yeah. That's what we want. Python, import LangChain. Oh, I know what's going on. Rookie mistake here. So I called my Python file langchain.py, but test langchain. That's the problem. So it was thinking that we were referring to this Python file. Python was like, I don't understand. You're trying to import this Python file, but it's not a Python file. So that's the problem. Don't name your Python files after packages. All right, so we got an answer here. It says, my name is John. Okay, that's kind of weird that it would decide to have a name. Maybe if we run it again, what happens? My name is John. Okay, so apparently GPT's name is John, is what we're learning. Let's see. Prompt templates, manage prompts. Okay, so not only are we going to import this, but then we're going to also import from langchain.prompts, import prompt template, this one. And then you can say, let's comment out this. Input variable product. What is a good name for a company that makes product? Okay, so basically it seems like what these are is a way to have a couple different variables there. So you could say something like my name and then your name, and then you could say, what is, hello, I am my name. What is your name? And then I suppose you could prompt.format. This is just like more annoying. What? Prompt.format. Okay, just like, why not just use f strings directly? Like, why have this like fucking prompt template variable thing? Right? These abstractions are just, sometimes they're just more heavy than they need to be. Prompt type, there's a config. It's a class method prompt, like what? What is all this extra crap here? So unnecessary. Chains. Let's see. Dynamically call chains based on user input. So far, the chains we've looked at run in a predetermined order. Agents no longer do. They use an LLM to determine which actions to take and in what order. When used correctly, agents can be extremely powerful. We'll show you how to exactly use the agents through the simplest, highest level API. In order to load agents, you should understand the following concepts. So we have a tool, a function that performs a specific duty, such as Google search, Python REPL, or other claims. The interface for a tool is expected to have a string as input and a string as output. Okay, so you can install Google search results and then get the Google API key. So why don't we go ahead and do that? Let's pip install Google search results, and let's also go ahead and copy the key that we have for Google that is stored in our thumbnails repo. I think I called it google.txt, and we'll copy it to here. And we're going to have to go into our git ignore and also add it in there. So we're going to add google.txt. And then let's go into our LangChain. And we're going to set the Google key. And I believe that's not the correct environment variable. You want to set it to that. All right. Let's make sure that that runs. Okay, seems to run fine. And let's go back to it here. All right, so now you got to import 4 extra things here. You got from a LangChain.agents. Agents import, and we're going to want to import agent type, initialize agent, and then load tools. Okay, so first thing you do here is you load the tools. So let's get rid of this prompt template here. The tools that it seems to be loading are the search API and then the LLM math tool. We don't really know what the LLM math tool is, but maybe it's a calculator. Then we initialize the agent with tools, the language model, and the type of agent we want. So then you need to call this initialize agent, which has all these fucking args and quargs that are a little bit unnecessary here, right? Like, why not? Tools is a sequence of base tools. LLM is a base language model. Agent is an agent type. Okay. And let's ask it a question. So agent.run, and we're going to say prompt. What is the temperature in Austin today? Let's see what that gives us. Missing key input. All right, so you see here the problem is that Copilot automatically added this. But really what you want is that. So let's run that. Entering new agent executor chain, action search, action input, temperature in Austin, Texas, got an error from search API, invalid API key, your API key should be here. Okay, so it's not liking the SirPeep API. Is this not Google search? No, it's not. This is not Google's search API. This is a different search API called SirP API. What other tools do they have available? Do they have a actual Google tool? Google search. Here you go. This is the one we want. Let's use Google search. Let's give it access to Google search. And let's make sure we're using the correct. Yeah, in here, in our thumbnails, we got replicate Google API key is the name that we want. So make sure that we're setting the Google API key correctly and rerun this. Did not find Google CSE ID. Please add environment variable Google CSE ID. Let's ask ChatGPT what the fuck Google CSE ID is. It's the ID for the Google search or Google custom search engine. Go to the Google custom search engine website. Okay. Oh, I don't want a custom search engine. All right. Let's just say Wikipedia. So Google search seems to be basically if you had Google search enabled on your specific website, and then you would be able to say on this specific website, basically. So let's instead say, what is the zip code of Austin, Texas? So this is a question that I feel like Wikipedia should be able to answer. Or actually, let's say this. What is the capital? How do you spell the whatever? What is the state bird of Texas? Let's see that. I feel like you should try to use, you need a Wikipedia API wrapper? Dude, what the fuck? All these tools suck. None of them even have a working thing. You need to import pip install Wikipedia. Okay. Jesus Christ. All right, now let's see if we can finally get it to use a tool. All right, so you see there, you see how it kind of prompted itself and it finished the chain. Okay. So all this blue text is internal monologue to the LLM. So this is the question that I asked it. All I asked it was this: what is the state bird of Texas? Then the LLM asked itself, I should look for a bird that is associated with Texas. And then it decided, okay, I need to use Wikipedia. And then I'm going to use Wikipedia to search for the state bird of Texas. And then it went into Wikipedia and it found this page, list of U.S. state birds. And then it got this big like blurb of text here. Blah, blah, blah. And then it said, okay, I'm also going to find the list of Texas state symbols, and then here's the following is a blah, blah. And then it thought to itself, it said, this looks like the best source for my answer. Okay. Action, Wikipedia, action input, state bird, Texas. So it did the same thing again twice. So you see how it searched Wikipedia once, and then it searched Wikipedia again. So that's kind of unnecessary. But then it was able to say the northern mockingbird is listed as the state bird of Texas. So it was able to read that Wikipedia page and then answer its own question. And once it answered its own question, it gave us the final answer, and then it finished the chain. Right? So that right there, I feel like as much as it was kind of annoying to set up LangChain, or what was this called again? Yeah, LangChain. This is the power of these kind of tools, right? Is that you basically get it out of the bat. Get all that extra stuff there. Let's close that. All right, so that's what a chain is. Okay, so now we're done with chains, and let's look at memory. Memory, add state to chains and agents. So far, all the chains and agents have been stateless. You may want to add a chain or an agent to have some concept of memory so that it may remember information about its previous interactions. Simple example of this is a chatbot. You want it to remember previous messages. So again, this kind of, how does LangChain differ from AutoGPT? It's basically the same thing. They're And they're both basically the concept of an LL. They're basically the chain of thought concept and then the tool former concept, and then you combine them together. I think that LangChain seems a little bit cleaner. I don't like that LangChain is like very opinionated and has all these different abstractions that you have to like remember. It's kind of opinionated here refers to whenever like a code base or a repo forces you to use all these different abstractions in order to use the repo. But looking at this documentation, looking at the kind of support, looking at the integrations, it seems like LangChain is better, right? A little bit more mature. When you go here and like you go into AutoGPT, and we were looking at this code and the quality was pretty low, and then here it says use stable, not master, right? Like they're telling you that some of the branches are fucking broken. Like, to me, this makes me think that AutoGPT is just not as good. Right? Like, I don't know. AutoGPT, I think, is more famous and people are talking about it, but it's largely the same thing, just of shittier quality. Yeah, you can actually buy GitHub stars, though, so don't read that in too much. And I also think that there's kind of this like lemming effect where like a lot of people, they're not AI people, so they don't understand and they don't know how to judge the quality of a GitHub repo, but they don't want to feel like they're being left behind, right? So they'll come in and they'll be like, wow, this looks great, and then they'll hit a star, but they never even read the code, they never even use the code, they don't even understand what the fuck this is doing. They just want to feel like they're part of the hype train, right? So out of these 114,000 stars, right, like how many people are actually doing something with this, right? But I also feel like both AutoGPT and LangChain are just going to die, because at some point OpenAI is going to release this exact tooling, right? Like there's nothing really amazing about this. It's just a bunch of Python code that just gives you like integrates memory and some agent and like has some abstractions on top, and like same thing with AutoGPT. So I feel like OpenAI is just going to have their own version of this, right? They're probably not going to call it, maybe they call it Auto or like Chat Friend or something, I don't know, something like that, but they're just going to make their own version of it, and then as soon as OpenAI has their own version of it that's like directly integrated with GPT, nobody's going to use LangChain and nobody's going to use AutoGPT. So it's kind of like, I don't know. Is it worth me spending time to like learn all these abstractions that LangChain has? Probably not, right? But if I didn't have a YouTube channel, I probably wouldn't be doing this. Okay. Let's see. So we were looking at the chains, and now they want to add a memory to the chain, right? And you have this short-term and the long-term memory. So the short-term memory is basically context, which is like within the prompt. And then you have long-term memory, which is going to be probably the external vector database. But they're not going to actually have like an external hosted database here. They're going to have a local database that just stores it in memory. So we need to import another thing here. We need to import conversation chain. Yeah, like already look at how polluted our repo is. Like our little script is. We have like 3 different submodules with 6 different like abstractions, right? So like that's really annoying. LLM, temperature, conversation chain. Entering new chain. Okay, so basically it stores the conversation in a object called conversation. So you can make a, let's close out of this, and let's say conversation, we're going to call it conv, equals conversation chain. LLM equals LLM, and what the fuck is this? Let's do that. Verbose equals true. And we'll say output equals conv dot predict input hello. And this is another thing here that I don't like, right? Like, for example, when you're using an LLM, if you remember here, you say LLM and then you feed it the string directly, like this. But when you're using a conversation chain, you have to say conversation chain dot predict and then input equals. So you see how this is not consistent, right? These two things are not consistent at all. That's where the confusion comes in. It's like either make these consistent and have this one also be like this, right? Or make this one like this, right? Like don't flippy floppy on your abstractions and have different ways of doing the same thing. That it's no bueno. So uncomment that. Current conversation. How are you? Okay, let's see. Print. Output. Let's see what we get when we run that. Cannot import conversation name from conversation chain from LangChain. Okay, so this actually needs to be imported directly from LangChain. I found LangChain to be very costly when using the OpenAI API. Anyone else had the same observations? Probably. These agents, like, there's a lot of requests here, right? Like, it's every single one of these, like, thoughts is a request. So it's like if you used ChatGPT, right? You type in your question and then it opens a new ChatGPT window, types in its thought, sends it back, types a new ChatGPT window. So it's like performing for every request that you give it. It's performing probably a dozen different requests, especially if it's an agent and it has like this like prompt that it keeps doing. So yeah, it can get expensive pretty quick. What am I looking at here? Oh yeah, it was here. Okay, so it's storing the information in that conv object, so we can actually probably come here and let's add more to this conversation. Hello, I am good. What is the state bird of Texas? Let's print the output at every single time step. Let's put a breakpoint here because I'm curious. I want to inspect that variable. All right. So we're here, and I'm interested in this conv variable. So conv is a conversation chain. It has some special variables here. Can I like get rid of this? Class variable fields memory. Here's the memory. Infer is default, set config is complex. So annoying. So unnecessary. Let's keep going. Okay, here's the next one. Finished chain. So it's actually using a chain object underneath all of this. And let's go again. All right. So I guess that's it. Is basically just it stores information in this chain, and then maybe why would you use a chain as opposed to anything else? Chat models have a variation. They expose an interface where chat messages are the inputs and outputs. Oh my god, so there's a bunch of different messages here. So there's an AI message, human message, system message, and chat message. So these are in OpenAI's API, right? You can specify different things. So you can specify the system or the assistant or the user. So there's kind of 3 different roles that you can play when you ping ChatGPT, and that's what they're kind of letting you know here, is that you can have a message where the role is the assistant, which is what they're calling AI message here. You can have a message where the role is the system, and that's what they're calling system message here. And then you can have a role where the message, or a message where the role is the human or the user, and they're going to call it human. So this is another kind of annoying thing here, because the way that OpenAI calls these, right? OpenAI has these abstractions as well, API reference. Documentation. OpenAI. Here we go. So API reference in making requests. Yeah, so give me the Python one. Documentations. Chat completion. Yeah, you see here how basically you can either be the system, you can be the user, or you can be the assistant. But in LangChain, rather than using these 3 exact words, system, user, and assistant, they're going to use the word system. Instead of human, they're going to say, or instead of user, they're going to say human. And then instead of AI, or instead of assistant, they're going to say AI. Hey Hugo, I wanted to share some encouragement. I always learn something from these streams and save them to come back for weekend learning. I appreciate it, man. I'm glad you can find benefit from these streams. And Mabongengi, the crazy thing is that auto GPTs are way cheaper, like not even close. I mean, it just means that whatever you're doing on auto GPT, you're using less which have access to tools like the internet. Yeah. So, I mean, we can look at the, I don't know if I want to pull up my OpenAI usage, but you can look at the usage broken down per keys, right? So here's my usage. Let me zoom in here and scroll down. But you can go into OpenAI and see what you're using. So this is today, right, April 26th. And you can see that just in this morning, we've had 12 requests, right? And maybe this is what you're referring to. I'm sorry, I'm like having a hard time pronouncing your name, but Mabongeni. The number of tokens is going to determine the price of the request, right? So if you have here 2,800 tokens for the prompt, 3,000 tokens total. So this is probably the prompt where it went into Wikipedia and it found the state bird of Texas, and then it asked to find that. So it copy pasted all of that directly into it, right? And that's probably where you see these just monster tokens, right? So that's probably why it's expensive. It's because it's using a lot of the context length in order to ask questions, which is the most expensive part. Let's close out of that. From LangChain, import chat OpenAI. What? Look at this. Even more abstractions. Now you need this one here, chat models, and then chat LangChain.schema. So you got more stuff. Look at this. Look at that. Look at that. Look at all these abstractions. Why can't I hold all these abstractions? Chat OpenAI. Okay. So we're going to make an LLM. Let's comment out of that. Say chat equals chat OpenAI. Can you get completions by passing a single message? Okay, so this allows you to basically make these without. So you are a helpful assistant that translates English to French. Human message. Translate this sentence from English to French. I love programming. And then you would have, it will complete it by adding an assistant message. So if you wanted to do this in the raw ChatGPT API, you would basically just have a dictionary, and then in that dictionary you would have two dictionaries, right, like this. And then you would have role, and then system, like that, and then role, and it's not human, it's user. So I don't know, you tell me, what is better? Is it this? This is not a dictionary, this should be a list. Or this. All right, this is what LangChain is saying. This is an easier thing to read than this, but I'm like, I feel like this is better, right? And this is also more backwards compatible because now you're doing it directly in the way that OpenAI does it. So system is what you want the agent to actually do. So let's see. OpenAI documentation. There's like a specific chat here. Yeah. So messages. The role can either be system, user, or assistant. So system basically tells the ChatGPT what it is. It's like kind of like it wakes up and it says you are X. Right? So for example, in my thumbnail project that I made, I have a function that makes a color, right? Where is it? Resize, draw text, remove, GPT color. So I made this little function here that generates a color. And the system prompt is you generate unique and interesting colors for a crayon set, blah, 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 like that. So what you're doing with the system is you're telling the GPT what you want, right? And then the user is your actual prompt. And you can also provide examples with the assistant itself. So you could have like messages here where you are the assistant. We, right? And then it'll use that as context, and the LLM is going to try to be self-consistent. So if it responds in a certain manner, if you give it a history where it's responding in a certain way, it'll tend to respond in that certain way. Okay. So let's close this, and then apparently you can just feed that. So why not this? Why not input? Yeah, exactly. The system conditions GPT about what kind of answers it should give. It tells GPT what it is, right? So, for example, here, let's try something crazy here. You could say, you are a good doggo that barks back when talked to. And then the human, I'm going to say, good doggo. And then if we do that, what is it not liking? Unmatched, colon, this is not liking that. We need to get rid of this chain here. So comment out all this crap here. All right, and it ran. I guess we got to print the output in order to actually know. Chat, and then chat messages, batch messages, chat generate batch messages. You need to print the result. So this is the result. There you go. So it actually said barks happily. You see here? But I don't want it to do that. I want it to actually write the word bark. So I could do something like this. Assistant message. I guess it's not assistant message. What do they call it? AI message. So AI message. Content woof. Human message. What is the state bird of Texas? And now it should just answer woof, right? No, it actually answered. Bark. Bark. All right, now let's see. Let's see. So now, in a way, you can actually think of this as a form of kind of supervised learning, right? Where you're giving it the input, and here's the output, and then here's the input, and then here's the output. So you're kind of teaching it, you're telling it. It's like a form of in-context supervised learning, which is fucking crazy. All right, let's run this again. I feel like now we should be able to get it to say bark. No, dude, it's still... You do not reply with text, only bark. Let's make it a little bit more kind of imperative here. Jesus Christ, it does not care. This is starting to make me think that maybe it's not actually doing what I wanted to do. Let's try GPT. No good. No good. Why? All right. I don't know. I have no explanation, guys. I don't know why the in-context supervised learning is not working, because it was working in other things. But maybe the way that it's implemented in LangChain is no bueno. You can make use of templates. So you can make templates called message prompt templates. All right, so even more abstractions for us to use. This one, not only is it more abstractions to use, but they're not even stored inside. Like you have a langchain.chat_models, and then you have a langchain.prompts.chat. Like all of these abstractions should just be at the root level right here. You are a helpful assistant that translate blank to blank. Okay, so this is basically just allows you to format. And let's see, chains. You can use chat chains. So system message from template, human message from template. The LLM can be a chat object. If the LLM is a chat object, why is this not right here? Right? Chat OpenAI inherits from base chat model. Base chat model inherits from base language model. And base language model inherits from base model. What does OpenAI inherit from? OpenAI inherits from base OpenAI. Base OpenAI inherits from base LLM. And base LLM inherits from base language model. And then base language model inherits from base model. So both OpenAI and Chat OpenAI are of type base model, right? They both kind of, in the inheritance tree, they both come from the same object, which to me means that they both need to be in the same module. You need, like, if they're the same type of object, they should be in the same module, not in two different modules like this, especially two different modules with different names. Human message prompt from template. Okay, agents with chat models. Agents can also be used with chat models. You can initialize one using agent type chat 0-shot react description as the agent type. So make sure to put this little magic, set this magic quark to this magic variable here, or else it doesn't work. So here it's using the tools. So this is the tools that we were using before. Here's the agent prompting itself. So you have the thought, you have the action, observation, thought, action, observation, thought, action, observation. So thought, action, observation is actually comes from, at a high level, the reinforcement learning kind of loop. So in reinforcement learning, you have state or observation, state, action, reward, right? And then observation again. So that's the basic loop of any agent-based reinforcement learning system is you have an observation, then you have the state, then you have the action, so, and then you have the reward. So what do these mean? So observation would be like, here's what I observe about my environment. The state is, here's what the environment is. And then the action is, here's the action I'm taking in this environment. And then the reward is, here's the reward I'm receiving back from the environment. So there is no reward in this case because this isn't like a reinforcement learning system directly. This is just an internal thought process. But they do have observation, state, action, although here in state they say thought. Okay, now we're going into memory. So they said that they had short-term memory and long-term memory. You have chat prompt template, messages placeholder, system message prompt template, and human message prompt template. So the system prompt is basically telling it to give answers. messages placeholder, history. So I guess they create a template so that you can basically fill in all this crap later. Human message prompt template from template. You know what I think the problem is? I think the problem is that the person who wrote this is a JavaScript developer. I think I just discovered the secret. So in Java and like TypeScript and those kind of languages, like everything is an object, and like the objectification of like literally every single concept in your code base is pervasive, right? And Java object names are also kind of very intense a lot of times, right? Like this type of stuff here: conversation buffer memory, chat prompt template, system message prompt template. Like this to me just screams Java developer. And then if we go to the quick start, right, we see that actually they not only do they have Python docs, but they also have TypeScript and Java docs. So I'm starting to piece it together, and I'm starting to notice that the person who wrote this is all just Java. Yeah, it's not design issues, right? It's because like someone could look at my code and say, hey, this is wrong for these reasons, right? Like once you get to a certain point in code design, there isn't a right answer. It's more just opinions. So I'm a Python developer, right? So to me, like I appreciate syntactic cleanliness and like being able to read things quickly and having like kind of a consistent, simple to use experience. But people who work in Java, like they want types on everything. It's like everything inherits from everything, and there's this giant web of abstractions that all inherit from each other, and that you have to use them all like that. So all I'm doing here is I'm noticing that the design patterns in this repo are very reminiscent of someone who like writes JavaScript code. And that triggers someone like me who writes Python, because for me, it's like having to write all this extra crap. Like, look at all these imports. Like, look at all this crap here. Like, I just feel like this is so unnecessary, right? Yeah, it's not just getting started, but it's also like it makes things easier to learn. It's so much more annoying to learn if you don't know these abstractions, right? It's like you want to do a simple thing and you know what you want to do, but you don't know what the word for that thing is, right? It's like, I want an agent that can store its memory. And the guy's like, oh, well, you want a LangChain agent type, and you need to use the AI message system message prompt. And I'm like, how the fuck was I supposed to know that, right? It's like you can't know it unless you understand it and become an expert of that system yourself. Okay. Sorry, I'm kind of raging, guys. I don't know. I feel like maybe this stream is negative. You know, I try to be kind of happy and positive, but like sometimes I just end up raging at the code. Maybe I need more coffee. That's the problem. Or yerba mate. You know, I don't like being a hater. I want to spread love and positivity into the world, but it depends on who you talk to, RW. I'm sure that there's plenty of Java people that will look at me and just call me a Python kitty and like, you know, tell me I'm basic and stupid because I like Python. But I don't know, man. Python is just so much better than everything else. I drink yerba mate. I live in Austin, Texas, deadly data, but yerba mate is very good. Been drinking it for a while. I don't know who got me into it. Yeah, I've messed with, like I've done work in other languages too. I've used C# a lot too. C# is what you use in Unity, and it's kind of like in between Python and C++. I've also used C++, but at this point that's like a long time ago. C++ was like the first thing that I really used kind of in college and coming out of culture. Yeah, it's from Argentinian culture, but I'm not from there. No soy argentino, pero me gusta la yerba mate. Or el mate, right? I don't think it's feminine. But yeah, out of all the languages, kind of over time, I feel like I've consolidated to Python because everything is in Python. Machine learning is in Python, and machine learning is life. So All right, we're kind of getting distracted here. Let's see what we can go. Models. So there's 3 different types of models. You have LLMs, chat models, and then text embedding models. Okay, what are text embedding models? The embedding class is a class designed for interfacing with embeddings. There are a lot of embedding providers, right? Just yesterday, or not yesterday, 2 days ago, we were looking at the Hugging Face tokenizers, right? So Hugging Face provides tokenizers, which are embedders, right? They convert text into an embedding, right? An embedding and a vector are the same thing. An embedding is just another word for a vector. So embedding is a vector representation of a piece of text, right? So this sentence is actually not correct. This is useful because it means we can think about the text in vector space. Yeah, so the whole point of turning a piece of text into a vector is that you can then, in their case, they want to be able to store information in a database and then use the embedding vector as kind of the lookup, as the index, so that you can use similarity search to find it, right? But the reason that people use embeddings outside of just similarity search in databases is because you can, they're all the same length, right? So every single token, every single word within your sequence now becomes a vector of the same length. So you can compare tokens to other tokens and so on. So actually, if we go into their embeddings, I'm sure that they actually just use Hugging Face. So let's save this. Let's close that. Let's open up here. Not in speech-to-speech. Let's go here into LangChain. Let's go into LangChain. Chains. Doc store. Vector stores. Here we go. Maybe tokenizers. The word embedding is not on here. Let's see. Inside vector stores. It's not it. LangChain, embeddings, this is what we want. So these are all the different embeddings that they have available. Base, Cohere, Fake, Llama CPP, SageMaker, TensorFlow Hub. So I mean, one thing I will give credit to for LangChain is they have a lot of integrations. Like, look at this. You know, you can use so many different embeddings, right? You can embed using the Hugging Face transformers, tokenizers. You can embed using SageMaker, which is Amazon, kind of like machine learning tooling. Llama CPP. So Llama is the language model that Facebook released, and Llama CPP is a C++ like port of that someone made that runs very quickly. OpenAI embeddings. I didn't know OpenAI had an embedding offering. Let's see. What does this do? OpenAI embeddings. Embed OpenAI embeddings. Wrapper around OpenAI embeddings models. What is it actually using? Where is the actual embedding? What is the embedding func? embed with retry. So you see how this is like 3 different functions that all call itself. So really what you want is embed with retry function, which is this one. And this one actually doesn't even do the actual work. This one calls a different one here, embed with retry. So we got absolutely jack shit from that. Let's look for embeddings here. Embeddings. So in OpenAI, you can ask, you can get the model, so you can tell it exactly what model to use, and then you can get the input, which is the string that you want, and then it'll return an embedding vector. Okay. So that's one way to do it. The other way to do it is with the transformers from Hugging Face. I wonder which ones are better. Hugging Face embeddings, sentence transformers. Yeah. One thing they don't have here, though, is no, there are as many different kinds of embeddings as there are models. So even within Hugging Face, there's like hundreds of different embeddings you could use, right? And every time there's a new model, there will be new embeddings. So is there any standardized tests? Not really. You just basically have to use them in your application and then see what there is. You can look at them, right? So like embedding vectors word similarity, right? So the vectors that, there's like a picture here that I'm looking for, but yeah. So the embeddings represent vectors in a high dimensional space, right? And the way that the embedding spaces are created, different models, different embedding models, right, will produce different vectors for the same tokens, right? And some models will have, like for example here, generally helicopter, drone, and rocket are all going to be very similar vectors in an embedding space. Clip is an embedding. You can take clip, right? Clip embeddings. Yeah, so for example, let's see this. The cool thing about clip is that the embedding space is, you can use it for both images and text. So both images and text can be projected into the same embedding space. And that's actually how they trained clip, is that they basically said the embedding for this text should be similar to the embedding for this image, right? Open image in new tab, right? So the way that clip was trained is you basically have images, you have text, you encode the text, you encode the images, and then you have a loss that says, okay, the text should be very close to the image in embedding space. Generally, the bigger the model, the longer it's been fine-tuned or trained on, and the more data that it's been trained on, the higher the quality of the embedding, right? So we were looking at Dino V2 last week, which is a computer vision model, and that is trained on the largest amount of data, and it's the biggest model that I've seen for vision. So the embeddings that come out of Dino V2 are probably the best embeddings for vision, but I have no way of proving that, right? There's no kind of like theoretical proof or guarantee that you could give to say that the embeddings of Dino V2 are any different or better than the embeddings from Clip, right? I think rather than context and task dependent, I think the choice of embeddings would be based on hardware and system requirements, right? If you want something that runs on a cell phone, right, you're probably going to want to use API requests to get an embedding. So then you're probably going to want to use the OpenAI embeddings API, because then you can just get the embeddings directly from an API request. You don't have to do any local processing. If you have a giant GPU cluster that you're training a computer vision model on, you're not going to want to send images to Hugging Face to embed them with Clip or something, right? You're probably going to want to use Dino V2. So depending on what hardware you have available and how much money you're willing to pay, and like whether or not you care about sending your information out, you're going to use different embedding techniques. I feel like I'm just like sloppy with my words today. Aleph alpha asymmetric semantic embedding. Yeah, generally just pick the biggest possible model that's trained on the largest amount of data for the embedding vector that you want. Of course, specific to the modality. So embedding text is completely different from embedding vision and images. So here we can see this one. I don't know what Aleph is. It's probably something we don't have an API key for. But this is a test text. Let's see, let's close out of this. Yeah, we don't have a key for that. Let's use the OpenAI embeddings instead. All right, I guess it did something. Print doc result and then print query result. Right, so both of these embedding vectors should be basically the same. It's going to be very difficult to actually see that. So let's put let's ask compare both embedding vectors. Right, and you can use SciPy here. There you go. So actually, let's do this. Let's say the dog jumped the fence. We're going to come up with some sentences here, and then we're going to show you how the distance of these embeddings changes. The cat jumped or climbed the tree. And then here we're going to say the man baked a cake. And then we're going to say text A, B, and C. And let's not embed this text. Let's do this. Let's do result A equals text A. And then let Copilot complete the rest of those. And then let's do this. Print distance between text A and text B, text A and text C, text B and text C. So now if we run this, here you go. So the distance between dog jumped the fence and man baked a cake is 0.21. Distance between cat climbed a tree and man baked a cake is 0.18. And the distance between dog jumped the fence and cat jumped the fence is 0.12, or climbed the tree. So you can see how it kind of makes sense. the dog jumping the fence and the cat climbing the tree are more similar to each other than either of these is to the man baked a cake, right? And whenever you're using a vector database, this is largely what you're doing, right? Is that basically what the vector database has done is it's taken all your text, let's say you feed it like an archive document. It's taken all those sentences and it's turned them into these embedding vectors. And then when you say, hey, I have a specific question, it's going to say, okay, I'm going to take that question and I'm going to take that text and I'm going to compare it to every single little piece of text, every single embedding vector in this database. And the one that it's the most similar to, that's the one that I'm going to give you, right? God, so many abstractions here. This is just so annoying here. Tools, toolkit, agent, executor. What the fuck is this? Agent executor is an agent with a set of tools. The agent executor is responsible for calling the agent, getting back, and action input. Question answering over docs. Even yeah, generally you don't really have to do that. Generally the way that the vector databases work is that they store the vectors in such a way that you don't have to literally do n comparisons for every single thing. It'll basically say, okay, this is close to this region of space, so therefore I'm going to limit the search to this area, right? I don't know exactly how they do it, but basically lower means it's more similar. Yeah, so the cosine of angle, right? If you guys remember from your basic trigonometry, right, the cosine of an angle is the adjacent over the hypotenuse, right, the b over c. So if you have two vectors, right, and an embedding is a vector, it's just a vector in a high dimensional space, right? So when you think of a vector, normally you're thinking of like two numbers or three numbers, right? It's like a two-dimensional vector or a three-dimensional vector, but an embedding is like a 512-dimensional vector. But the trigonometry rule that still applies, right? So the cosine of two 512-dimensional vectors, the angle between them is going to be smaller if those vectors are kind of in the same direction, pointing at the same thing, versus if they're very different, the angle is going to be bigger, so the cosine is going to be higher, right? So when you're doing similarity comparison with cosine, it's literally just the angle between two vectors. It's that just at a higher dimensional manifold, not just a two-dimensional or a three-dimensional Euclidean space. Okay. So this is how the ingestion works here. It loads the documents using a document loader. Then it splits the documents using a text splitter. So it'll split it into sentences or maybe like chunks of sentences. Then it'll create embeddings for each of those little words, each of those splits. And then it'll store the documents into a vector store, which is just a vector database where the key is the vector itself. Generation. Now that we have an index, how do we use this for generation? So you retrieve the user question, you embed the user question, you look up documents in the index relevant, construct a prompt value from the question. What the fuck is a prompt value and a prompt template? This is just more abstractions that we need to know. A prompt value is what is passed to the underlying model. Okay, and then a prompt template is a template of prompt values. So unnecessary. Let's see what tools they have. I'm just kind of curious about that. So let's go into LangChain, doc store, Hugging Face, prompts, Utilities, archive API wrapper. What is this? Wrapper around archive API. There's an archive API? What the fuck? That's pretty cool. I didn't know there was an archive API. So apparently you can search archive for papers in Python. Oh shit, that's pretty badass. Yeah, so I mean, you can basically get any archive paper, is what it seems like. And then it will just take that archive paper, read it as a PDF, and cut and paste every single chunk of it into ChatGPT. Which is why, Bongeni, like you were complaining that it uses up a ton of your API. That's why, right? If you ask it, hey, can you give me an archive paper for this? It'll go and it'll find it using the API, and then it'll feed the entire thing as if you literally copy-pasted the entire paper into a GPT window, which is why it just seems kind of crazy. A lot of requests. Okay. What else do we got here? Wolfram Alpha Power BI. Here are all the different LLMs that it supplies or supports. So you of course have OpenAI, you of course have Llama. I know Anthropic. Anthropic is like a kind of a OpenAI competitor, but they're not as big or as good. What is Petals? Oh, Petals is the Bloom models. We've used the Bloom models on this channel. We're reading science papers with the Bloom model, and it was actually pretty good. Stochastic AI, large language models. What is this? This just seems like a... It's using BERT. BERT is a very old model at this point. Okay, I don't know, just some shitty startup that wants you to use their product, basically. Cerebrium. Wolfram Alpha API wrapper. Wolfram Alpha API wrapper inherits from base model. That's kind of... Yeah, Pydantic here. This is no good, dude. See, look at all these types. These are all very specific types. Positive int, negative int. It's JavaScript right here. I can smell it. It smells like JavaScript to me right here. Okay. Oh. I don't know. I'm running out of steam, guys. What are we at? We're at 2 hours and 11. I think that might be it for me. Can I give a overall review? So my overall review of LangChain is that it's a little bit too many abstractions. It's a little too complicated, a little inconsistent. It just reeks of JavaScript. Maybe if you're a JavaScript developer, this is great because it has a JavaScript API, right? But if you're a Python developer, I feel like you should just use something that's a little bit more lightweight. Okay, so that's what I don't like about it, is that it's kind of too many abstractions, too opinionated, too kind of over-engineered. What I do like about it is that it has a lot of integrations, right? Like, the amount of integrations that this has is very impressive, right? You can use all these different LLMs. You can use all these different vector databases and stores. You can use a bunch of different encoders if you want to use encoders, right? So encoding and embedding is the same thing. You can have all these different tools here, Google Search, Wolfram Alpha, Wikipedia. So I think the most powerful thing about LangChain is that they have all these different integrations, which makes it very powerful. I don't think AutoGPT has that. But yeah, that's what I think is good and what I think is bad. And am I going to use this? Probably not. I'm probably going to use the OpenAI API directly. And then at some point, OpenAI will release a version of this. And that version that OpenAI releases will be better than all of them. And then at that point, it'll just be worth using that. So if you have something that you really, really want to try out, maybe you can use LangChain. But if you're writing Python, I would just say just continue to use the OpenAI API directly. And just wait for OpenAI to release their own version of this. These streams are much appreciated. Your way of explaining and sharing is excellent. God bless. I appreciate it, man. I love the support. And yeah, man, have a good week. I'll probably come up with 2 new papers or something to talk about tomorrow and on Friday as well. But yeah, have a great day. Like and subscribe. And drink some yerba mate. This is like the best form of caffeine available.